Hello, hello. Starting a bit early here, so we're gonna wait about 10 minutes for people to show up, because I announced that I'm officially starting at 6 finish time, which is in a bit under 8 minutes. Oh, hello, Kid Christopher. Looking forward to getting a glimpse inside the creative process. Been enjoying the new record. Thank you. Yeah, that's what this whole stream is gonna be about. Looking into... I guess I said mostly the code, but I mean that is a big part of the creative process for me. But yeah. While we wait, I'm just gonna keep playing a bit of the album, and actually I might need to fix the aspect ratio on this Mac OS 9 machine, so just a moment. Well, that was easier than I remembered. I guess it pays off to set up OBS sources properly. While waiting, I'm having some green tea. This is a sencha that I bought yesterday from Nari Tea here in Helsinki. We actually had our Algorave Helsinki meetup there for the first time. The owner, Patrick, was very kind to lend us the space. And it's a good sencha. I forget already what it was called. It's on the package, which is over there, but... yeah. By the way, if you're on TikTok, then maybe type something in the chat so I can check whether this chat overlay is actually working, because it's kind of inconsistent sometimes. Okay, hello Gampy. Apparently it's not working, so let me try to fix that. Okay, now we got that one. We lost the message history on the Twitch side though, but I guess we'll manage. That's the funny thing with these three platforms, that some of them send the entire message history when you connect, and then, well, Twitch doesn't. I could probably store it myself and have it recoverable for when I need to reboot the overlay, but haven't done that yet. Okay, getting closer to 6 o'clock. Trying to remember if there's something I still need to prepare before we are ready to go, but probably not. This should be fine. Okay, 1 minute to go. I didn't really think of what to do while waiting, so I guess it's fine to just let the music play. Alright, that is 6 o'clock. Actually, I don't know if you can see it, but on the iBook here, it actually says 6:01, but that's like... it's wrong. I don't have this hooked up to the network, so the clock is a bit off. Pigeons have such beautiful colors. Yes, absolutely, I totally agree. I think this is a very nice shot. Okay, so welcome to the stream. This is Nested Behind the Scenes. Oh, thank you, Bob Mester, for the rose. Yeah, Nested Behind the Scenes. So, Nested is the name of my new album, which was released last Friday. And it's an album entirely made with code. Some people might wonder what exactly that means, so... because entirely with code might to some imply that it's like purely synthesized, but that's not the case. There's samples in there, but it's all composed and produced with code. And what that means is a few of the tracks are made with Super Glider 2, which we're gonna start with here. A few are made with Tidal Cycles, and then one is made with Sonic Pi. So that's 3 different systems and programming languages actually for making music. Live coding music, as it's known. Basically genius level music. Well, I mean, I don't know about that. It's just another type of music notation, I think. You don't need to be a genius to do it. In fact, many people who don't have prior experience with programming get into both music and programming through live coding. Well, I say many people, but of course it's a relatively niche scene, but several people, at least. And I mean, it's a great way to learn programming if you're interested in music. It's probably pretty motivating to do something like that, and I mean, creative coding in general is really fun and inspiring, and yeah. Oh, hey, green coder. Many. One, you know, one. Yeah. It occurs to me that I should show you right now the Bandcamp page for the album, but I can't do that because I have now the macOS 9 computer plugged in and it doesn't have a functioning web browser. Okay, but here's what I can do. I can open simple text and I can type here ulu.bandcamp.com and can make the font a little bigger. That's great. So now we can have this advert on screen all the time. Okay, so let's get started. I'm not gonna go in the tracklist order. I'm gonna go by programming language because that's just easier tech-wise. I don't have to keep jumping back and forth between different things. So, well, okay, we're starting off in tracklist order because the first track on the album is called isström, and that one is in fact made with SuperCollider 2 running on macOS 9. Which is what I have open here. And actually I should probably bump up the font size on this as well. Not sure what's good, maybe 18? Because I'm hoping to have it readable also on the TikTok side, which famously is mostly used on phones with a relatively tiny screen. So hopefully this is readable there as well. So, SuperCollider 2 is the older version of SuperCollider, which is now in version 3.13. It's readable. Okay, nice. Thanks for letting me know. Yeah, so for SuperCollider 2, I ended up developing my own pattern system because I thought there wasn't one built in. Turns out there is, but I still made my own. And I have a whole series of live stream recordings about that on my YouTube channel. The playlist is just called Retro SuperCollider, so like if you want to see the whole painstaking process, then you might enjoy that. So the way this works, if we just take a look at like the general structure of the program, here I have some comments helping me remember the notes and the scale of this whole thing. So the first thing I do is create an MFT pat control, and that is a class that communicates with the MIDI fighter twister, which is my controller here. This one. And it doesn't do it directly because I cannot, I mean, I can plug this in via USB into the iBook, but there's no macOS 9 driver for this thing, although it is class compliant, but there's not even a macOS 9 class compliant driver for MIDI devices, so yeah, that doesn't work. One of my dreams when I have a lot of time is to actually try making a class-compliant MIDI USB driver for macOS 9. I think that would be useful to the larger classic macOS music making community, which again is a very small thing, but you know. So the way this actually works now is that I have this controller plugged into a Bella, which is a small single board computer based on the BeagleBone Black, I think. And that one is running a small supercollider patch to read the data from this, and then it sends it over via OSC. And so I have the iBook plugged into the Bella with Ethernet, and that's how I get data into supercollider 2 from the controller. There's another nice thing that happens as a result of doing it this way, and that is that I'm often performing with two laptops. So I'll have this one and then a slightly newer laptop with tidal cycles. And then because I have the controller hooked up to the Bella, which sends data over OSC, I can just easily have it send the data to different addresses. So with the same controller, I'm able to control both, you know, supercollider 2 on one laptop and then tidal on the other laptop. So that has turned out to be very handy. Okay, so what this code here is just saying is set up the controller on port 8000. Then the control class has a play method, which you give it a number, an integer, and then it plays the pattern with that number. We're going to get to the patterns in a moment. So by default, this starts patterns number 7 and 9. And that's just so that immediately when I start this track, I have something happening. I don't need to like manually trigger that. Then here I'm loading all my samples. Got a kick drum, snare, a few different hi-hats. There's a few other samples that I recorded myself. So actually, why don't I start by showing you what those actually are? Oh, hello, Reclosia. So we have this one called Tongue. It's actually from a steel tongue drum. Let me show you that. I think it's down here. Whoops, wrong scene. So this is the thing. It's a very tiny steel tongue drum. It has been marketed also as a rain drum, but I don't know, that seems kind of weird to me. It's probably not that interesting to put it in the rain, and also probably it would oxidize. I don't know, I haven't tried and I'm not gonna. So it just sounds like that. And so in the code here we see that I have 3 different samples. So there's hits, which is basically what I just showed you. Then there's drags and hit drags. So the way I did those was I used the other end of this mallet, and this is a bit hard to do while holding this in my hand, but I'm gonna try. Also, I need to turn down the gate here. So this kind of quick dragging movement over the tongues to get a more of a non-transient type of sound. And then hit drags is just like a hit and then drag. Okay, then another instrument that I'm using here is a tambourine. And this is just a cheap plastic tambourine. And I actually made it's like a live recorded loop, or I'm doing some kind of... I'm not actually a good tambourine player, but I managed to do it for that one recording. Okay, I'm gonna show the final instrument that I recorded, and then I can show the sounds that are generated based on these. So the final thing is a... Hold on, what is it in English? Is it a harmonica? I need to check. Yeah, a harmonica. But it's not a normal harmonica, it's actually this Genshin Impact merch type of thing. So this is, I don't know if you can see, but it's merch of the character Barbara in the game, and there's like a little shiny pendant that comes with it. But then there's also this super tiny harmonica. And yeah, it says Barbara on there. It's probably a bit hard for the camera to focus on this, but yeah, this is like really tiny, and it's got only 4 notes. Really hard to play any actual melody because it's so tiny. So I don't. I just recorded a bit of, like, I guess, droning on it, and that is this sample here, huuliharppu, and that means harmonica in Finnish. And yeah, that's a funny word because it means mouth harp or lip harp, but a harp is a completely different type of instrument, so not sure what's going on there. Okay. So with that, we have the sample loading. Here is where I define my tempo, cycles per second, so that's going to be 145 BPM divided by 4 times 60, which is 4 beats per bar, and then 60 seconds per minute. Okay, and then we get to the pattern data. In SuperCollider 2, I have actually at least 2 versions of my pattern system. This is the earlier one. Nowadays it looks a little bit different, but like the principles are mostly the same. So we start off with this kind of block here that sets up these variables and gives them values in lists, and then on each event for that pattern we advance through each list, and if we reach the end of the list then we just loop. So for example here the kick pattern is made up by doing this kind of pattern where we start off with a 0, then we have rest, 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 and lots of rests, and then some kicks in there to get kind of a, what should I call it, a pattern with some syncopation and variation over time. And all of these notes are 16th notes as specified by the duration here. And then after that we have an arrow, and to the right of that arrow is a function that actually turns the data coming out of this pattern for each step into an actual sound. So here, in case of the kick drum, it's just saying sound.play1, and I can do that because sound is an instance of a sample class that I've defined, and I gave it a method play1 that'll just play that sound once and then stop. So that happens on like every note event. But let me jump around a bit because I'm gonna talk about the pattern that actually starts off the track. I'm gonna resize my windows a little here first. Okay. The one I want to start off with is the steel tongue drum pattern, helpfully labeled here with a comment. So what's going on here? Well, we're taking the sample with the name tongue that was loaded earlier. Then I'm setting up all sorts of values here, and let's see if I actually even remember what all of these are. But in this version of the pattern system, if I want to have a value that changes on each evaluation based on some function, then I have to write it like this. So there's like offset is func, and then this specifies the function. So offset is going to be a random number between 0 and 1 on every step. And then here also the duration is randomized, and that's because this pattern is not really a rhythmic one. It's more of a ambience pad type of thing made with granular synthesis. So basically this is saying the duration of each grain should be between 1/64th and 1/8 note, chosen randomly and with an exponential curve. Okay, then we have attack, release, and length for each grain. We have randomized panning, randomized amplitude, randomized rate, and this means the playback rate of the sample, which has the effect of both slowing it down if the rate is below 0 and also pitching it down. You know, basic resampling. So here I'm randomizing the rate. It's chosen from 2, 1, 1/2, and 1/4. So it's always going to be in tune with the original recording, but it can be 1 octave higher, 1 octave lower, or even 2 octaves lower. And then I'm also multiplying it by a random choice between -1 and +1, and that has the effect of making the sample play either backwards or forwards, depending on this value. Then I have a cutoff parameter. I think that is modulating a filter somewhere down here. And resonance, also random. Bend. Right, so I have this kind of, what is it called? Like a glide effect, I guess. So the note starts off from a lower octave or a higher octave, and then it glides up. And then also the bend time that applies to these, which is randomized between apparently 0 and 0.75. So then we get to the function that actually does the synthesis. And here I am first of all taking the value of the controller knob that corresponds to this pattern. I think it was number 7, so probably the blue one here. And yeah, I'm taking that value, apparently giving it 2 different names. That's a remnant of something different I was doing before. Scaling the random cutoff between 200 and 12,000 hertz. Then basically doing the pitch glide here with an envelope. So I'm defining a variable rate, which uses both the rate value and the bend value, and you know, glides from the bend value to 1 times the rate value. Okay, then if sound index is 1, so I think what that means is wait, this is actually never assigned, so I think this is not being used. It's just, yeah, another remnant of something else. But yeah, then again we use the sound.play one with all these parameters that we've set up, and then there's an insert section here which just adds a resonant low-pass filter. So we can hear that. This is what it sounds like. And now if I turn up the filter cutoff here, kind of gets brighter and more present. Yeah, that's the power of granular synthesis. I could listen to just this instrument alone for like ages. I'm really happy with it. Then we have another pad type of deal using the harmonica. This one is written a bit differently. It's actually not using the pattern system at all. So we have an empty pattern definition here, an empty function to turn pattern events into sounds. But then we have a second arrow, and what that does is define an insert effect. But what that really means is that it's defining like a signal processing block that goes after everything else, and it's like persistent. It stays there all the time. So here I decided to do a slightly different type of granular synthesis, and let's see if I can remember how this works. So I think the idea here is that I basically just have there's 4 instances of this code, but each of these instances is a sample player, and all it's doing is playing basically random sections of the harmonica sample, and that section, the bounds of it vary all the time, and like the length and everything. So basically it's playing short varying loops of that sample, and yeah, there's 4 of those going on at once, and I think there is maybe... No, there's not actually any modulation based on the index of the sample player. So they're all actually operating with the same logic, same parameters. It's just that they're going to have different random values from the LF noise here, and from this LF noise, and this one. So I guess that's just to kind of thicken up the sound of that. I can play only that by commenting out 7 and uncommenting 8. And again, I have some filter cutoff mapped to this knob on the controller. And when I open up the filter, we get this kind of slightly clicky sound going on, which I think really adds to the sound of this instrument. Wait, I'm using the wrong knob here, this one. Okay, and now it's getting brighter. So yeah, here you can hear the little clicks going on. And that's not actually part of the harmonica recording. What that is simply because I'm playing like loops of the sample, and there's gonna be discontinuities from where it ends and where it starts looping again. So those produce little clicks, and usually that's something you want to avoid. But here I'm feeding it into the filter, so it's kind of like softening the clicks a little bit. And I think it turns into this very pleasant kind of sound. Almost like running water or something like that. So those are the pads in this track. Yeah, we have kicks, we have the tambourine. The tambourine is maybe not that interesting. I mean, it's mostly playing like the loop that I recorded. The one thing maybe that is interesting here is this trans block. So that means transformation, and that's a way in this pattern system that I can apply a function to each event that's coming out of this pattern and manipulate those. And what I'm using this for is basically I guess like a stutter type of effect. So I have a function called ply, which takes an event, and if I'm doing ply 2, then it doubles that same event, but both of them fitting into the duration of the original event. So it makes 2 of them and shortens each of them by half. And then there can be also by 4 and 8. The probability with which that is applied depends on the position of the knob. I think number 2 here, or index 1, but number 2 in human counting. Yeah. So maybe we can have a quick listen to that, just to show you the interactive nature of it. I'm gonna do single line comments here, so this is easier to work with. So by default it just sounds like this, but then if I start turning up this knob, we start to get these stutters. And I think that's a fun take on, like, because it's quite an organic sound otherwise, but then this turns it into a bit more robotic thing, so there's a nice little contrast there, I think. Okay, then we have, well, we have the snare pattern. That's nothing too interesting really, it's just sample playback. For the hi-hat, I'm also doing sample playback, but there's a bit more going on with the transformation here. So in this case, it's like the bass pattern is half notes, apparently, and then the transformation does something interesting with that, which is it's again applying ply. Well, this time it's ply width, so it's again doing 8 copies of the same event with 1/8 the length, or 16 depending on a random choice here, which is based on the position of the knob, this one, and ply width. This is a function that is heavily inspired by the function of the same name in tidal cycles, that lets me apply a function to each repeat of the note or the event. So I can do like these iterative changes, and what I do here with it is I modify the note value, which here is going to be used for the playback rate, so it's going to like pitch the sample up or down. And that happens either up or down, which is specified by the direction value here. So this syntax looks a bit strange, but this is a way of like defining multiple pattern values at the same time. So for example, this here is on the first step we have the note -12 and the direction 1, then we have note -2 and direction -1, and so on. So it's just like grouping together related values. So depending on that, this pattern is going to go either up or down, or that hit of the hi-hat when it repeats. And yeah, then I'm converting the note into a ratio, frequency ratio. Computing the duration here, because it needs to be the minimum of the sound duration and the duration of the event. Then doing play 1 again, and doing some panning. And the panning here is also manipulated here in this ply width. And basically what that does is it's doing like an alternating panning between left and right. So let's hear that. No, that's the wrong pattern. That is index number 3. Oh, and also it's picking different... Wait, is it picking different samples? Yeah, there's 3 different samples, so it's picking different ones for each hit. And then there is the repeating and rising or falling effect going on. And now if I turn this knob up, then some of the time we get the faster repetition. And it turns into this like sliding effect. And this track, it's called isström, which means ice stream in Swedish. And you know, for the whole track I was inspired by like wintry, icy landscapes. So I guess the slidiness here comes from like ice being slippery or something like that. Okay. Then we have the bass. That's just a very painstakingly manually written melody, or like note sequence, using the phase modulation oscillator in SuperClutter 2. And it looks like we're using the same envelope for both parameters here. It just gives it a bit of like a transient Yeah, maybe nothing super interesting about that one, but we can hear it. And on this one there's not even any like interactivity with the knob, it's just that bass line. Then we have what is called as rise fall here, but it's like the main melody in the track. So here again we have a sequence of notes. Each of them plays 3/16 notes. Then, hold on. Yeah, here's where the variation system in my pattern thing comes into play. So each pattern can have variations, and the way I toggle those is by holding one of the bottom buttons or knobs here down and then clicking the pattern that I want to change the variation of. So the way that works is that in the pattern system it just sets a integer to either 0, 1, 2, 3 or so on, depending on what I pressed here. And then based on that variable, which is called mvar, the m underscore prefix stands for magic, and that's where I put like magic values that are included in events but not specified here. So basically the way this works is that the variations are going to change the octaves happening in the melody. So at variation 0, at variation 0, we're always getting the value 1 out of here, so the frequency is going to be multiplied by 1, and so unchanged. At variation index 1, we get 2 out of here, so that's going to raise the melody up 1 octave. And finally, at variation value 2, or index 2, we take the multiplier here from this mul pattern here, so that's going to vary between 1, 4, and 2. So that's going to make the melody jump between like 3 different octaves. And then it's again a PM oscillator, amplitude envelope, panning. Then it goes into a low-pass filter and a feedback delay down here. So let's hear that. Right, and the filter is controlled by the knob here. So I can open it up. And I can switch to variation 1. So it's now an octave higher. Or variation 2 for the jumping around version. And that's how I get a lot of mileage out of that one melody, by varying it over time in the track. Okay, then we have what I think is the final instrument. It's called Quack. This is another synth. And again, I like just manually written out the notes in here and their durations. It takes a lot of time to do this, by the way, because it's kind of like trial and error, and if you want it to like last for, let's say, a specific amount of bars or cycles, then you have to make sure that all of these durations add up to that cycle. But yeah, that's all that happens in the pattern. Then in the synth, I guess there's a bit more going on. Oh yeah, this one is using the memory feature of my pattern system. So what that means is that it remembers the previous event, and we can access the values from the previous event. So the way I use that here is to create basically portamento, so sliding between successive notes in the melody. Alright, okay, so it doesn't actually remember the previous event, it just remembers whatever we put in there during the execution of this synthesis function. So here I'm actually storing in last frequency the current frequency, so then at the next event it will be the last frequency. Then we have frequency envelope, a bit of frequency envelope. I think that's for like a vibrato. Quite a subtle one. Oh, hello, Wokiapi. No, long time no Pulu. Yeah, I guess it's been a while. Yeah, vibrato here, and then I'm doing something twice, so we're basically doing this code block twice. So I guess this is doing two different sawtooth oscillators, and maybe that's just for like chorusing effect, I guess. I mean, that would make sense, yeah. So yeah, for the chorus, I'm using this list of -1 and +1 as a starting point. I always get that value here, either -1 or +1. Then here for the chorus, I basically multiply that by 0.024, which is just a value I found through trial and error. And that, I've been talking about chorus, but what I meant to say is detuning. So detuning, yes. So it detunes both of the voices by, what is this, 2.4 cents in different directions. And then we also multiply by the LFO, so we get that vibrato. And then there's panning, which, you know, separates the two detuned voices a bit in the stereo field. Then there's filter, low pass once again. Two amplitude envelopes for some reason. I'm sure there's a good reason for that, but I can't remember what it is. Then as the insert effect for that, we have an all pass N, which is again a delay effect. So let's hear that one. And I can turn up the filter cutoff here to make it a bit brighter. And yeah, there's this rising attack also on the filter cutoff. Or maybe that's on... Is it the cutoff? Probably. Yeah, I guess so. Because this is a sawtooth oscillator and not the PMOC. Okay. And maybe you can hear why I ended up calling it quack. It kind of has that quacky feeling to it. Okay, that's isström. Maybe I can play a little bit of how it all sounds together. Although you should listen to the album really. Okay, just a quick run through of all the sounds. Not gonna do like full performances first because I haven't practiced and my timing is sloppy, and also because go listen to the album. I made proper recordings for that. Alright, that is isström. Then what else do we have on the album? We have Dreamstream. And Dreamstream is actually the very first track I made with Supercollider 2. And maybe it's kind of noticeable in that it's a bit simpler in structure and sound design and everything. Did I have it this big before, or... No, I think it was... Oh, hold on, actually. I think this 18 is what it was before. Okay. So, in this one we have somewhat fewer samples. There's just a snare sample and then a few percussion hits. But everything else is synthesized. So here is the kick drum being synthesized, and that's just a simple sine oscillator with a frequency sweep from, what is it? Okay, it's MIDI note 36 and then 2 octaves above that, so whatever that is in hertz, I don't know. So that makes a very simple kick drum, but for this track it kind of works. And above all, it's a very simple pattern, so here I kind of leaned into this minimal vibe, both in sound design and structure. But then there are maybe a few sounds that are like a bit more complex to add some interest, and they end up standing out more because of the rest of the track being so minimal. Okay, then we have a hi-hat synthesis, and here it's also, yeah, purely synthetic, and this is really just a white noise oscillator being high-pass filtered at 8 kHz with a bit of resonance on it. Then we have a random decay time between 1 and 4, whatever the units of that actually are. Oh yeah, it's time scale, so actually it's just scaling this percussive envelope here by those values, so I don't know what that ends up being in absolute time, but it doesn't matter. Also got, I believe, random amplitude for a bit of like organicity to it, and yeah, the amplitude value is like a magic one. I don't need to actually multiply by it here, it's done automatically. And then there is multiplication by the knob value to the power of 2, which is just a way of saying that I want this knob to like control the volume of that hi-hat. So actually maybe this time I'm gonna add these up, so we'll hear now both the kick and the hi-hat. Well, actually we won't hear the hi-hat at first because I need to turn it up from here. But yeah, you can hear all the variation going on there. Then we have the percussion track or pattern. So that's using the percussion samples loaded earlier, and we are varying the note number here, but in this case the note number is actually being used as an index into the samples. So samples at perc here is actually an array of 3 samples, and then this is going to just pick which one of them to play. Oh. TikTok needs me to complete verification because apparently I'm inactive. Let me also turn those sounds off. Okay. Yeah, where was I? Well, yeah, the synthesis part of this is just playing that sample once. And here's where we actually index into the array based on the note number. Then as the insert effect, I believe we have feedback delays again. As you might be able to tell, that's one of my favorite effects. So we have delay time modulation. So there's the maximum amount and the amount happening for that. And then the modulation is just a sine wave, pretty slow one, being scaled by the modulation amount. Then, yeah, we're using the feedback delay. Here is where the actual delay time modulation happens. Or no, sorry, here. This is just because we need to set like a maximum delay time that can actually happen, so that's what I do here. Feedback amount. Then I think here is an insert effect that goes like into the feedback section of the delay, so I'm doing a bit of filtering there. both from the low end and the high end. And also putting quite a lot of resonance on it. So then we just add those together, pan. Oh yeah, this I actually forgot about. There's a second layer of delay. So there's the one whose time is modulated and creates this weird kind of effect due to the modulation. But then there's another one that's more static, and that one just ends up echoing the modulated signal. And yeah, that's maybe the most complex sound in a way in this track. Let's hear it. Okay, I'll actually mute the other ones. And there's some modulation I can do here by turning the knob. I think it maybe increases the amount of delay time modulation, if I remember correctly. Yeah, I really like this one. Just trying to find out where the knob value is actually used. Oh, right here. Yeah, just as I remembered. So the knob value is scaled from 1 to dt mod max, which is 3, and that's how much the delay time gets modulated. Okay, then we have the snare. That's pretty basic sample playback, except there is kind of like a chorusy or phasing effect achieved by playing the dry signal and then a slightly delayed version of that signal as well. And so we get and here also the delay time is being modulated, so sometimes it like gets an upward phasing effect and sometimes downwards. And so those are the drums in this track. Then we have a bass line. Again, a very simple one. It's just 3 notes in a repeating pattern. Oh no, actually there's a 4th one. Sometimes every 4th cycle. And pretty simple synthesis here as well. It's a sawtooth filtered by resonant low-pass filter with a bit of a filter envelope on it and then an amplitude envelope. So, very basic sound design. That's how that sounds. Then we've got the pad, and if I remember correctly, I might be remembering wrong, but I think this was maybe actually the very first sound I really started designing with Super Collider 2. So this one is again not actually using the pattern system, and yeah, so it's not doing any per event synthesis because there are no events. Instead, everything is happening in the insert section. So here I'm actually using an impulse sequencer. And what this does is create a kind of sidechain compression or docking effect to the kick but I don't actually have a way in this system to wire up the kick into this pattern so that I would know when it's playing. So instead I just replicate the kick pattern here, and that's what gets used for the so-called side chaining. But yeah, then this is using the spawn ugen to spawn sine grains, and each sine grain is very short and has a frequency determined by picking a random number from this scale, I guess you could say, or collection of pitches in a scale. It's not like the full scale, but yeah. And so when we do that a lot of times in quick succession, then a lot of those grains end up playing like simultaneously and overlapping, so we actually get something that sounds like a chord, but with some interesting organic variation going on in it. Then there's a high-pass filter and amplitude envelope, which in this case is what does the ducking or side chaining. So let's hear that. Or not. Oops, I meant to play this one. So you can kind of hear the ducking happening, and it's not super clean. There's some clicks in there. I think the envelope is maybe just a bit too fast on the attack. But, I mean, together with the kick, it kind of works. Okay, then we have... the first melody. This again is just a sequence of note values. But then we also have a note multiplier, and you'll notice that this sequence is 9 notes. This multiplier is 5 notes, so those are like co-prime. They don't line up neatly, so there's gonna be like a polymetric type of effect happening. Then also duration is also co-prime with both of these, so there's even more of that polymetric sort of thing happening. So duration is going to vary between 3/16, 5/16, 2/16, or an eighth note, and again 3/16. So it's going to vary the rhythm and play notes from this in sequence, but where the rhythmic variations end up in this sequence is gonna vary over time. And that's actually one of my favorite generative melody techniques to do, like decoupled timing and pitch. It just lends itself to quite complex melodies. And that's actually an interesting thing, because such complex melodies are not always a good thing musically, because I find that these kinds of complex melodies can be quite hard to remember, because they're never really repeating quite the same sequence, or if it is, it's like not evenly shifted in time or something like that. So there's this interesting, I guess, artistic decision that you have to do. Like, how memorable do you want it to be, and like balance that with the complexity. Nowadays, I've often taken up the principle that it's fine for a melody not to be memorable, and this whole like generative way of making more complex melodies, I like to think of it as making something like dreamlike melodies, because dreams have a kind of weird logic to them, and they're always a bit shifting and hard to pin down. Like, you might look at the clock and it says one thing, you look at it again in a second and it says something completely different, and you know, this kind of thing. So in my mind, there's some kind of connection between this like generative style of composing melodies and dreams. That's just how I like it to think about it. And yeah, especially with like the memorability aspect of it, because dreams are often also hard to remember. So there's like a certain connection there if you think about it. So it's fine to make melodies that aren't memorable. It can be an artistic choice. Okay, then there is also some transformation happening here, and I think, yeah, it's kind of controlled by, the probability is controlled by the corresponding knob, which I believe is this one. So it's gonna divide each event into quite a large number of events, so there will be like a fast succession or repetition of those events. It's gonna do a bit of pitch bending with each succession. And yeah, again, based on the plywidth function. Okay, and then finally, the synthesis is just sine oscillator, again, keeping things very simple. Amplitude envelope. Oh yeah, but there is a bit of folding on it, so that kind of shapes the wave into something that's not quite a sine wave. And then there is again a delay with an all pass. Let's hear that one. So the folding is like a fairly crude distortion algorithm, but yeah, kind of works here. Then if I turn up the knob, we start to hear these repetitions and also the pitch bending happening in the repetitions. It's a little bit subtle, but it's like the pitch is falling slowly. Yeah. And then I think we have one more sound or instrument in this track, which is not even labeled with a comment, but it's the second melody, I guess. So again, we have a sequence of notes, a different sequence of durations. I'm doing again some glide type of thing, although I'm calling it bend here. Random release, random panning. And this is using the Formant synthesizer with a frequency envelope which is where we do that bending effect. Then we have random values for whatever the Formant parameters are. Formant frequency, BW frequency. I forget how this actually works. I think maybe by Command H. Oh yeah, pulse width frequency, yeah. I don't actually know the theory behind this synthesizer, I just play with the values until it sounds fun. Then there's a high-pass filter on that, and an amplitude envelope. And you'll never guess what the insert effect is. It's another feedback delay. Okay, let's hear that one. I think on this one the delay amount is controlled by the knob. Seems to be clipping a bit, I'm not sure why actually. Like, where is it clipping? Because it's not clipping when coming into my audio interface. Oh well. Okay, that is Dreamstream, the second track, not on the album, but not the second track on the album, but the second track that we're going through. There is one more Super Glider 2 track, which is called Strange Awakening. And before I go through this, I think I need to take a quick bathroom break, but I will see you in a few minutes. Damn, got some spam while I was away. That's a bit rude, I think. Deleted now, but okay. So, the final Super Collider 2 track is called Strange Awakening, and this is kind of a remix of I think it's actually my first album on SoundCloud. Let me check. Yeah, my first album on SoundCloud under the name Pulu, which is called Cocoon, and that's a generative soundscape I did for Hibernation, which has been now 4 iterations of something like, well, it was originally a quiet party for queer people, but then it turned into an archive of trans dreams, and the soundscape has been at those events every time. And the soundscape is like a 6-part one going through 6 phases of sleep, and the final one is called Awakening, and in that one there's a melody and a pad which I kind of pulled into this track called Strange Awakening, and then did something quite different with it. Okay, so again we're loading samples, no surprises there. Oh, maybe I can talk about one of the samples, which is called RFX. So what RFX is a, well, it's originally just a sine wave, a pattern I made with a sine wave. It was actually on a live stream some time ago. I forget what it's called, but on the live stream I was experimenting with my modded radio as kind of like an FX unit for Super Collider. So the way that works is I route audio from my audio interface into a line input jack on the radio. No, sorry, that's not how it works at all. Sorry. Let's try that again. So the way it works is I take the output from my audio interface into an FM radio transmitter. Then I turn on the radio, I receive that signal over the air and send it from a line output back into the computer via the audio interface. And like by itself, that doesn't really do much. I mean, it converts the signal into analog, sends it over the air, and I guess you get a bit of analog something out of that, maybe some noise too. But interesting things happen when the transmitter frequency and the receiver frequency don't quite match, but almost, because then you get this kind of frequency modulating distortion kind of effect. And that's what I did with this sample called RFX. It's a sine wave baseline fed through the radio pipeline with slightly mismatching frequencies, and that's what gives this kind of analog distorted character. Then Oh yeah, there's a few other interesting samples in here, I guess. Like there's some drum breaks, there's percussions, there's a tom, a synthetic one, I think. There's ZR noise, and what that is, ZR stands for Zoom recorder, and it's not here, but I have this Zoom H5 portable recorder. And it comes with like detachable microphone attachments, right? So one of them is like an XY microphone. That's, I think, the default one that comes with the device. And that one also has a line input you can use to feed like 3.5mm mini stereo into it. So, okay, why am I telling you this? Well, because the line input on mine is a little malfunctioning. So sometimes when you unplug the cable from it, it kind of gets stuck in some way. And when it is stuck like that, it produces all sorts of strange noises. So what ZR noise is just a recording of that noise. And yeah, I use that for some, I guess you could say almost percussive, but not quite, elements in this track. Then there is Puijon sarvi. So Puijon sarvi here actually refers to a hotel in Kuopio, a city in Finland, where I was during summer 2023. There's a Sokos hotel, Puijon sarvi, which is where I stayed. Because I was like a visiting artist for Anti Festival, there to look at the programs of that year, or experience them, I guess. So I was staying in this actually quite luxurious, I think it was a 2 or 3 person room technically, and I was there all alone, so wow. But in that room there was a small, maybe nightstand or like a table made of metal, and because of the way my brain is when I find any kind of resonating object, such as a metal table, I will try to hit it with my fingers or nails or knuckles or various objects to see what kind of sounds I can make with it. And that's what I did. And yeah, this sample is basically just a recording of that table being struck in various ways. And maybe I can start with that because it's the first sample or the first sound you hear on this track. So let's see, where is it? Here. Oh yeah, and this is now using a newer version of my pattern system. So whereas previously we had these lists here with the pattern value definitions, now actually what defines the events is a function, and in there we set environment variables, but again using lists in much the same way. Except this time I don't need to tell it that this list contains functions, it just magically figures that out and calls the functions, if they are functions, to get values. And that ends up... Hold on, I'm getting disconnected. Let me check something. Because my internet connection has been a bit unstable lately. I think it is because my quite old router is, let's say, nearing the end of its life. So I try to turn off everything that causes extra internet traffic while I'm streaming. including my backups, but the backups actually automatically just started now, so maybe that's what is making these problems. Okay, I've turned it off again, so hopefully that helps. Yeah. So we have a function where we define environment variables with the lists that end up creating pattern values. And they can be functions, or they can be not functions. The nice thing about this is that I can combine functions and constants, or like static values, I guess. Although I don't think I'm doing that here, but I can. Yeah, so this is another granular synthesis type of deal. Oh, also, now the very first element of each pattern definition, actually, I have to give it a name as a symbol, not just as a comment. And additionally, I can tell it here to play, like, immediately. Okay, so yeah, this is another granular synthesis thing based on the hotel table recording. So I'm using the knob value here, the sample, and defining the rate as a function with some randomization. So we're doing a weighted choice between going forwards or backwards in the sample. Sorry, I have to drink some water. Okay, I think I dropped something, but I don't know where it fell, so I'll figure that out later. Yeah, so we can go forwards or backwards in the sample playback, depending on the knob position. And it's basically modifying the weights of this random choice by the knob position. So I think when it's all the way to the right, I think it's gonna, this is gonna be 1, so it'll be a 50-50 chance between forwards and backwards. And if it's all the way to the left, then it's just gonna do backwards, because this is gonna be 0. Then we're also randomizing the octave, again with a weighted choice, heavily weighted towards the 2 upper octaves. Then we have something called ext, which is a random value. I'm not sure what that does, we'll find out later. Oh, well, okay, we'll find out now. So, I guess it means extend or something, because that is modifying the duration and also the length, which are different things. So the duration is the length of the actual event, and the time until the next event in the pattern triggers. But then length is how long does each event actually play. So they can be different, and if the length is longer than the duration, then it means we'll have overlapping events, which often is what you want with granular. So I guess both of those depend on this ext value, which is randomized, and it's scaling them in different ways. Okay, then we have offset, and I believe that's just gonna be the sample playback position for each grain. We have attack and release, random amplitude, and here's a comment saying goes into shape. What does that mean? Well, it means the amplitude from this is fed, or well, the whole sound from this, including the amplitude, this amplitude which it gets scaled by, is fed into shape, which is a distortion effect. So tweaking this will not necessarily make the sound just quieter or louder, but it'll also affect the distortion. So that's just a reminder for myself that this is non-linear, basically. Random panning. Again, we have apply transformation, now written slightly differently, but the same idea again. Also, that's doing something with the knob value. Again, using that as a probability to trigger the transformation or not for each event. So yeah, then here the synthesis, well, it's just sample playback with all these parameters that we set up in the pattern. And then there is a feedback delay and the shape I mentioned, which is a distortion. So let's hear that. I believe that one plays by default. Oh, one change I need to make here is that this is currently set up to record, but I don't want that right now. I think this was maybe the right knob. No? Was it this one? Oh yeah, this one. So now if I have it all the way to the right, we can hear that there's like some sharper transients, which is because we're playing the table hits forwards some of the time. But then if I dial it back, we have just the backwards playback, and that makes it like softer. So that's how that works. Okay, let's go through the other stuff from the start. So we have... Yeah, in this track I don't actually have a kick at all. I'm using this tom sound as kind of a kick. So super simple pattern here, playing every 2 bars, just one hit, with a bit of distortion on it. And then there's a delay, which is controlled by the knob position. Oh, Super Glider crashed, and with it, actually, the whole operating system. That happens sometimes, but since my mouse does now not move, I think I have to force shut down the whole thing. Okay, this might take a second to bring back up, so let me turn on the music again. Because booting this iBook is not always super reliable, but now it looks fine on the first try. Yeah, because sometimes it just like starts up into a black screen and it doesn't even get into open firmware, which is where I need to be in order to boot macOS 9. But luckily it worked fine now. So we get to enjoy some macOS 9 startup. Which isn't fast, but also not super slow compared to booting macOS 10 on my hacked Mac Pro. Strange Awakening. This is where we were at. And let me grow the font size again. Okay, let's try that again. Okay, so then I wanted to show off the tom. So that's what that sounds like. And then if I turn up the knob, we get that filtered delay. Then we've got some percussion. There's a few different samples there being played in different rhythms, or like different positions of the rhythm. And which of those samples are played is actually controlled by the variation here. Somehow. Oh yeah, here. So basically, oh yeah, this is maybe a bit clever if I say so myself. So the number of the sample in the sample list determines at which variation index it will be included in this pattern. So at the default variation 0, we just hear the sample number zeros. Then at variation 1, we hear zeros and ones. At variation 2, zeros, ones, and twos. At variation 3, zeros, one, twos, and threes, which is all of them. So it's like a way to build up the pattern while performing. There's durations, there's lengths. Yeah, and here I'm setting the length depending on which sample is playing. So with some of these samples I want to play them all the way through, which is when I set the duration to, or the length to nil. With others I just want to play it for the duration of the event, which is when I set it to dir. So now this applies to sample number 0, sample number 1, 2, 3. Similar kind of thing for the amplitude, so different amplitude for different samples, again controlled by this array indexed by the note number. Some panning. There's also apply transformation here happening based on the knob position. Yeah, you'll find that I use the same kinds of tricks for a lot of tracks and instruments in those tracks. But I mean, if it works, it works. Although it does maybe at times become kind of a crutch, where it's like I don't know what I want to do with it, with this sound, so I'll just do this thing that I know that it works. So yeah, I should also try more new ways of manipulating events and sounds. One thing I want to do actually in SuperGlider 2 is build a reverb out of a feedback delay network. Because there's no reverbs that I know of built into the language, or like the UGen library. Okay, the synthesis here is again just sample playback. there's some weird stuff going on here to deal with the fact that some of the samples are mono and some are stereo, so this is detecting that if the output of the play one function is a collection, that means it's stereo, and in that case we take just the second channel, apparently. And then there's a shape distortion. So what does that sound like? Oh, I have the recording enabled again. Let's not. Oh, also. Okay. So at variation 0, it's just this snap type of sample. At variation 1, it adds this. I don't even know what to call that. Variation 2. And this is a percussion instrument that gets added, but I forget what it's called. Then variation 3. That's just adding in a hi-hat. Oh, and I guess I can show also that if I turn up the knob here, then the ply takes effect and creates these stutters, again, in quite a familiar fashion. Okay. I'm looking at the clock here and thinking I may have to speed up a bit because I have a lot of tracks to go through still. But on the other hand, the title ones are maybe gonna be a bit simpler to talk about. So maybe it's fine. Then we have the ZR noise that I talked about, the noise from my glitching Zoom recorder. This is also just sample playback, although picking different random positions from within the sample. Then adding a bit of shape and high-pass filtering it and amplitude envelope. Pretty simple stuff. So there's the noise thing. And of course it's meant to go together with the percussion. Like so. Then we have... Oh yeah, there's some drum breaks. So this is doing chopping of breaks in Super Collider 2. So the way that works is I have I'm calling it index, but really it's a position into the break sample. Playing quarter notes basically, but what that means is like a quarter note section of the sample. There's also a direction control here, so we can go forwards or backwards. There's rate being calculated, and this is just to sync up the loop with the tempo of the track, because they are at different tempos. Again, apply transformation for adding stutter effects. Shift, this is gonna do some pitch shifting of the chopped samples. And again, we have a very simple thing here. Sample playback with these parameters that we set up in the pattern. And that's what that sounds like. And if I turn up the knob, So we kind of get this pitch bend similarly to what I was showing on isström, the hi-hats. The first track of this stream. Okay, then we have RFX, which is the radio bass line. And this is really also just a sample playback because I recorded this in advance because I don't want to bring the whole radio setup to gigs and everything. Plus I only have stereo output from this iBook anyway. So I'm not entirely sure what this index calculation here is doing, because there's not really any kind of chopping of this sample that happens. But I'm sure it's there for a reason. Yeah, not sure about that. But anyway, we calculate offsets into the sample, so this is also playing fourth or quarter notes, but it's like successive portions of the loop, so those get kind of combined into a long loop. Again, we have sample playback. We have some attack and release on this to avoid clicks, I think. Then in the insert effects there is yeah, there's a feedback delay, and in that feedback delay path we have a high pass filter. Let's hear that one. So this is now the sine wave manipulated by slightly mistuned radio transmission. It sounds pretty weird. I really like that sound. I should experiment more with it. We can turn up the delay feedback. So we get a really long tail. And there's also a variation control on this, which all it does is switch to different pitches of this sample. So we kind of get like a little bass note progression there. And that's one thing I like to do in my tracks many times, is that at first the bass line will be quite monotonous, playing like maybe just a single note, could be in different octaves, maybe there's some fifths in there or something. But it'll be pretty monotonous and static, and then at some point into the track it changes into like a more varying pattern to add some drama. That's a good trick. Okay, then we have the table sound that I already showed you. And then there is the melody and the pad. So the melody is basically just making heavy use of this. Originally the PLA's pattern in Super Glider 3, but here it's my own implementation of it. So it's like this alternation. I think we've seen this in a few tracks already, but I didn't really talk about it. So the way this works is that on the first step, we use this sequence and it takes the first value of that. Then on the second step of the sequence, we take the 7 from here. Then on the third step, we take the 9 from here. Then the fourth step, we loop back here, but this time we take the second step of this sequence. Then again, we take the 7. Then we take the second step of this sequence, and so on. So, yeah. Again, this method of making generative melodies by this kind of interlacing logic. There's some octave variation. Here's where the... Oh yeah, the octave variation depends on which variation is currently active. So this is a bit like the melody in isström, I guess. Durations are fixed sequence. Attack, release is a bit randomized and also depending on the knob. Some kind of harmonic value here. Oh yeah, because this is FM synthesis, so I'm picking random harmonics to use. And also FM amount based on the knob position and also some randomness. Vibrato. I'm not sure if I actually ended up using the vibrato. I feel like I didn't. No, it's in there. Okay. But it has an amount of 0, so indeed, I did not use it. The code is still there, but it doesn't do anything. Okay, and so, like I said, FM. So this is our carrier sine wave here. This is the modulator, which also gets added together with the frequency envelope, because there's also a bit of like a pitch bending effect on these notes. On this one, okay, now we don't have a feedback delay, we have a ping pong delay, so it's bouncing back and forth between the stereo channels. So let's hear that melody. And it's gonna change as I bring up the knob. Then the variations. I think there's actually only 2 variations on this. So the second one just goes to the higher octave randomly. Or maybe not randomly, I think there was a sequence to it, but anyway. Finally, we have the pad. This one is doing chords in a very hacky way, because there's no polyphony in this event system currently. So what I do is I make successive notes in the sequence, but then just the 2 first ones always have a duration of 0, and that way I get polyphony, because it's playing multiple events at the same time. And this is honestly really annoying to work with, because it really limits the way the pattern can be structured easily. Like, say I wanted one of these chords to have 2 or 4 notes, then this duration sequence wouldn't work anymore. It would get all messed up, and yeah, I would have to work around it. So proper polyphony support is on my to-do list for this system. But here we are. Oh yeah, I didn't mention this, I think, but we're using the scale here which is an object defined here at the start. So this just defines what notes are in the scale. And then we work with scale degrees, which are then mapped to pitches with this scales note method. Then there's a weird thing that gets done here, where I'm manually retransposing one of the notes. I forget why I had to do this. I think it's because it might be because I'm using both minor and Dorian scales in this track, so this is just to take care of like changing that one note between them. Very hacky, but hey, it works. The durations I already explained. Length, again, it's the same difference between duration and length as before, so time between event versus actual playback time of the event. Attack. Right, the attack here is scaled to be relative to the tempo, or rather the inverse of the tempo, so that's seconds per cycle. And also scaled by length. There's just some math to make everything line up nicely. I can't explain it any better than that right now. FM amount and amplitude and panning. So this again is a 2-operator FM synth. Very similar, but this time the modulator also has some vibrato on it. And so does the carrier, actually. Well, not vibrato here, but I guess this is more like a slight pitch drift. And then we have distortion, high-pass filter, some really involved modulation. Oh, I think here I'm again doing like kind of a side chain compression type of thing, or like a pumping effect. So with this LF saw, the amplitude is gonna go down and then it slowly go up and then like continue doing that. And then there's a feedback delay because, of course. So, this is the pad. And the knob here, I think, controls the delay feedback amount. So that's Strange Awakening, and that is actually the final Super Collider 2 track. So now we're gonna move on to either Tidal Cycles or Sonic Pi. I haven't decided yet which one I'm gonna do first, but regardless, I need to switch over the capture input here to the other computer. So I'm gonna shut this one down. Yeah, so a bit of a setup break. I'm gonna turn on the music. I think that's the right wiring. Okay. And then I need to change the aspect ratio of the capture card. Like so. Then I need to move this controller. Well, not physically move it, but switch it to the other computer. Okay, let's see. I think I need to turn up the size here again. Hopefully this is large enough. Let me know if it's not. Also my windows are now all messed up, so let me move these around. I wonder why that happened. And I think that is fine. So, we are now in Mac OS X, and maybe I'll start with the Sonic Pi track actually, because that one's a bit unusual for me in that I don't really work with Sonic Pi. Except we were doing at the alternative party, demo party here in Helsinki, we were doing a Algorave Helsinki workshop and also live gigs, during which I found out that there is a Sonic Pi competition at the party. So that's tracks made with Sonic Pi, and also Sam Aaron, the creator of Sonic Pi, was visiting and doing a workshop as well as a live performance. And I met him and we chatted about a lot of live coding stuff, and very nice guy. Good chats, and also the gig was really great. But yeah, I decided to learn Sonic Pi in one night for the competition. So yeah, I spent the night before the deadline trying to figure it out, and ended up with a track. And many things here are not really done in a way that you're supposed to do things in Sonic Pi, because I was in a hurry and I was just doing the first thing that I know I could make work. But yeah, funny thing about this track is that or rather the competition that I made it for, is that the competition got cancelled because I was the only participant. However, then the track was moved into the more popular obscure music competition, which had more entries. That's what I mean by popularity. And I won that one instead. So it was all worth it in the end. Oh, I should show you the prize I got because it's kind of cool. I need to pick it up from over there. So what on earth is this? This is a sculpture made out of the front shell of a Genelec coaxial speaker. Genelec was one of the sponsors of the event, and then it's got this 3D printed cube on it that says Alt for Alternative Party, and then some text written in marker, you know, Obscure Music Competition 2024, first place, signatures of the organizers. Yeah, I don't think it says Pulu on here, but I got another, like a fridge magnet type of thing that says Pulu on it. Bob Mester says awesome. Yes, I also think this prize is awesome. It's like, if you really think about it, okay, bear with me here. If you really think about it, this is actually cooler than something like a Grammy or whatever the Finnish equivalent of that is. You know why? Because a lot of people have Grammys, but nobody else in the world has one of these. So yeah, I'm gonna put it back on the shelf. Okay, enough bragging about my glorious victory, and let's get into the track. So, right. So, I begin the code by defining some mapping functions, bipolar to unipolar, unipolar to a linear range between L and R, bipolar to linear, and linear to linear. That's just stuff I find myself using a lot. I define a root node. Then, instead of using the built-in tempo functionality of Sonic Pi, which I somehow felt would have taken too long to learn, I'm not sure if that's actually true, but that's how I felt. So instead of doing that, I calculate the duration of a bar. I keep the tempo at the default 60 BPM, but it's like, well, I want the track to be at 128 BPM, so I calculate the duration of a bar at that tempo. And then there's going to be a lot of math based on that number. The first thing here is I define the intro ambience. So this is alright, this is just defining like the function that actually makes that happen. So the actual track structure is gonna be at the very bottom. So here I set up these global effects. I have like just a gain, I guess, a high pass filter, ping pong delay, another gain, which is the input to the ping pong delay. So this is a cool thing about Sonic Pi. Compared to something like Tidal, is that you can actually stack these effects and like set up a signal chain with your effects in any order, which is not something Tidal does. We'll get to the Tidal tracks after this. But so basically this is functions that generate sound that go into this level or gain module, which then goes into this ping pong delay, which goes into the high pass filter, which goes into the final gain or level module. And the functions here are like the different elements of the song or track. And the way I have set this up is that I define starting times for each element. So the ambience one starts right at the beginning, but then there's a fade time and... Oh yeah, I guess this amp thing actually contains two elements. So there's the beginning ambience and then the bass pad that slowly fades in together with it. Then we have melody, which it's a melody with a bell, I suppose. Or it might be a kalimba in the end. I think I changed that at some point, but the name stuck. Anyway, then you have a kick that comes in hat, pad, melody, breaks, roll, that's a snare roll, and a finishing crash. And then the final bit here, this defines basically the end of the track. So at this time, all stop 0. We set premix of M echo, which is the ping pong delay. We set that to 1. So at that point, we start feeding everything that comes out of these instruments into the delay. And then we sleep until all stop 1, which is a bit after that. I don't remember how much exactly, maybe a 3/16 possibly. And then at that point, we set B level amplitude to 0, and that's this inner gain here. So basically that removes entirely the dry signal. Then we set the echo to 1 and the high pass filter mix to 1. So what this accomplishes is that in the end there's like a snare roll and a crash, and then everything so far gets fed into this delay, or like a short bit of it, and then that delay rings out for a few seconds and like everything else has stopped. So it's kind of an abrupt ending because it was like 5 in the morning when I got to this point and I really needed to sleep, so I just did that kind of abrupt ending. But yeah, the beginning ambience here is gonna be sine grains. I'm working with those again. With a bit of fading, I guess that sets up the envelope. And then this is all running inside a bit crusher. And for each grain, I'm also changing the frequency on the bit crusher, as well as the cutoff frequency on this filter here. And then it also goes into a reverb. And here's where I actually play the grain. So the note is defined by a random choice from these notes, plus 48 plus a random octave, plus the root note, which here is an E, I believe. Yeah, 4 is E. Yeah, then there's attack, decay, sustain, release, parameters for those grains, as well as amplitude, randomized, and randomize the padding. And then we randomize the duration until the next event and then just sleep that amount. And yeah, this is how this proceeds. Then we loop again from the start here. And this is a bit more like procedural or imperative than the super collider pattern system that I was showing, and definitely a lot more imperative than title. So I actually keep track here of variables such as t, which is the amount of total time that has elapsed in this pattern so far, and based on that I do like a fade effect. Oh yeah, and here's the other part of that, which is the base pad. So that's just like, it's also kind of a granular thing, but it's playing all the notes at the same pitch, except there's a bit of random detuning. And then they're kind of grains again, and they're overlapping and stuff. And again, we have like a random delta time here, so the duration until the next event. And here too we have this fade logic based on tracking the time elapsed so far. And that's what sets the oh, here we're not setting actually the amplitude for the grains, but we are setting something else. This normalizer. Oh yeah, there's a normalizer here which is wrapping everything, because I had some issues with like fluctuating levels in that bass pad sound, so with the normalizer it kind of, well, normalizes that. And then I'm just using that also as like a gain thing. So I'm setting the amplitude or the level based on this fade. Okay, then we have melody. Yeah, I'm not gonna, I think, play this individually now, because it's a bit of a hassle to do that, because I have to mess with these start times, and yeah, I'm not gonna do that now. I'm just gonna go through the codes here, and then we can listen to it later. But actually, maybe I can play this from audio, and then I can like comment on the various parts. So this is yaoi gagarin, and this is, now we're hearing the sine grains, a bit crushed. And now the bass pad begins to come in. Okay, and then the next thing that happens is the melody, which is no longer a bell, but a kalimba. So here I'm using some quite similar techniques to what I do in Super Collider 2. So we have a sequence of notes. Ring just means make it like a circular buffer, so it loops back to the start when it's over. So we have a note sequence, we have an octave sequence, and the lengths again are like coprime and a bit odd. And also a sequence of durations. And then here I have to keep track of this index variable manually. And here's where I do this trick to make this pattern start at the specified time. So if I is 0, we are at the first event, then we just sleep the amount of time given as an argument here, start, and otherwise we skip this. So this sleep only happens before the very first event. Then we use the kalimba synth. It might be a sample actually, I don't remember. We take the note at index I from this sequence, we take the octave at index I, multiply by 12, add 60, add the root. We have a envelope here as well with release and amplitude. This one was a very quiet instrument, so I had to really turn up the amp here. Random panning, clickiness. Oh yeah, I do think it's a synth because it has this clickiness parameter which changes the, I suppose, clickiness of the sound. So we get a bit of like organic variation in there. Then manual tempo scheduling, so we sleep. Basically we sleep for 1/8 of a bar multiplied by the current value from the duration sequence. So yeah, these rhythm sections of this code tend to be kind of complicated because I have to do all this manual multiplication by, well, the bar length basically. I mean, it's not that much more complicated, but you know, more than I'd like. So that's melody, and we start hearing it. There it comes. So we can hear that this setup again generates a fairly complex and not really repeating melody. I mean, it will repeat at some point, but maybe not so noticeably. Then we have a kick. This is pretty simple. It's just a sequence of durations. It's playing the built-in sample BD Tech. Oh yeah, because one of the constraints of the original Sonic Pi competition, which didn't happen in the end. My god, I just realized I have been showing you the camera all this time when I meant to show the code. Oh, okay. So you probably have not been able to see that. You should say something. Anyway. So just gonna quickly show this. So here we had the ambient sine grains with the reverb, the filter, the bit crusher, and then the live loop inside of that. And, you know, the logic to pick out the notes. I'm not gonna go through these again because we'll encounter similar things in the upcoming sounds. But yeah, note sequence, octave sequence, duration sequence, that kind of idea. Kick, duration sequence. And yeah, again, we're doing a sleep here to define the rhythm based on these numbers from the duration sequence. Multiply by bar, divide by 16, so these are basically 16th note multipliers. And that's how we get the kick. Okay, we got a bit more than that. I forgot that the hi-hat started at the same time. So in this one we have a very simple duration sequence. It's always a 16th note, but then we're picking different samples, and here's a somewhat interesting kind of logic going on, because we're not just looping through this sequence, but we're also using this offset sequence. So the way this works is when we have the index that loops through the sample sequence, we add to that the current value of the offset sequence. And so how that works is that okay, so the first 3 notes are gonna be offset 0, so then it's just gonna be this one, and this one. But then on the 4th note, we have an offset of 5. So normally we would be playing this one, but then we add 5 to that, so we go 1, 2, 3, 4, 5. Okay, that's actually the same as 0 in this case, because this one is exactly 5 elements. So okay, we do get this hi-hat, but then for the 5th one, we have an offset of 4. So then we would be playing this one, but instead we go 1, 2, 3, 4. So we play this one again. That's why sometimes you hear this repetition of the hi-hat, and it kind of mixes up the pattern, so it's not always the same sequence of hi-hat samples. Then there's a pan sequence, so it goes from side to side and like half to the side and also the center. And we're tracking both the index and the time for some reason. I don't think we actually do anything with the t variable here, which is the time. But yeah, so that's just a sample playback, amplitude, release, pan. That's it. So that goes on for a while. Then there's gonna be a pad. Here. So that's this one. It's using this synth called Hollow. And now we have a chord sequence. So it's actually just 2 different chords. We pick that. Then we use the method each with index to iterate through the notes in the chord. So we get the note and the index. We play the note plus 72 plus root. We put attack and release. And then, yeah, we use the index to position the note in the stereo field. So the first note of the chord goes left, the second one goes right, and the third goes... the second one goes in the center and the third goes right. So that way we have the chord kind of spread out over the stereo field. And then it's just sleeping 4 bars. And when the chords start, there also starts a fade in of this melody. So this is going to be again a very similar type of deal. Well, not quite. So, okay, we have a duration sequence. We have a note sequence, but here, well, we actually have a chord sequence, but we're not playing chords. Instead, we're doing basically arpeggios from these chords. And there's also an octave sequence for some variation. And also here we're using this offset logic that we saw in the hi-hats. So it's kind of combining all these things. And here again, doing the fade out with what is B? I guess B is just the number of bars that have happened so far. So a different notion of time. We're using the synth called Blade, another built-in, like everything in this track. Oh yeah, so we pick the chord actually based on B. So we take the floor of the current bar. Divided by 4, so each chord stays in place for 4 bars. Then that's where we get the chord, which is now here. Then we index into that with I and also the offset, so then we get a note in the chord. And then we apply the octave sequence and plus 60 plus the root node, and then we have random release, random pan, and here we apply the fade. Then this goes into a 10H distortion and into a delay or echo. And let's hear that. This is the melody now. So you can hear the chords changing. And then we get to my favorite part, which is the break chorus section, I guess, because as you might know at this point, I love to chop up breaks. And fortunately, Sonic Pi comes with the Amen break. So here this is strange because there's a variable speeds being used, but I don't think that actually exists. Does it? Oh no, it's passed as an argument. Okay. Let's see what's actually in there. Okay, the speed is always 2. Then we have these chops, which somehow controls how the sample gets chopped, and then we also have an offset sequence again. For some reason I decided to pass all this stuff as arguments instead of building them into the function. Maybe there's a good reason for that, I don't remember. So yeah, it turns out Sonic Pi actually has functionality to stretch samples, you know, to bars and whatnot, but here I just do all of that math manually. So I take the sample duration of the whole sample. It's a 4-bar sample, so I divide it by 4 bars. But now it's like bars in our tempo, so that gives me a ratio that I need to multiply by in order to match the tempos, and then we multiply by the speed, which is gonna end up being 2 here. So basically that speeds up the loop by 2, and that's what we want because the break chorus section here is kind of in double time, so it's faster, or like, yeah, same tempo, but twice the rate of notes, I suppose, compared to the underlying beat. Then here I calculate the starting positions of each sample chop, and the length is also based on the chops numbers that we get. I subtract what I think is 30 milliseconds from the length always, so that way we get I guess we get a bit of space between each chop, so it's like it's kind of like using legato in Tidal, but yeah. And we calculate the finishing point of that, and then if speed is less than 0, which I don't think it ever is in the final track, but in that case we just swap around the start and finish. We use the sample player, apply our rate, start and finish, and then sleep. And this is what that sounds like. And then the final bit of this is the snare roll. This is again quite simple. Here we're doing basically 30-second notes to match up with the double time of the chopped breaks. And yeah, it's just this snare dub sample. Although there is like a fade in on the amplitude and also a rising pitch as the snare roll progresses. And then the final thing that happens is this crash, and this is maybe the simplest thing of all. It's just waiting until the designated time, playing this one drum cymbal sample and stopping the pattern. So let's hear the ending of that. And there's the ping pong delay effect that I talked about at the start that finishes the whole thing with this sequence here. Okay, that is Yaoi Gagarin and Sonic Pi. Then the final thing is gonna be the title tracks. And how many do we have? We have 1, 2, 3, 4. And I have about 1 hour 20 minutes until I need to end, so we'll see. But I feel like this maybe shouldn't take as much time. So I'm gonna start up Super Collider. Maybe not have it in 2 windows. Start my UFO rave patch. And the first track we're looking at shall be Otherside Elevator. Startup title as well. And then Super Collider is still starting up, so we're waiting a little bit for everything to initialize. I think what takes the most time here is probably loading all the wavetables that I load by default. Oh, I notice here that I have some debug printing in place, so actually I'm gonna need to remove that and restart Super Collider. It's this one right here, because I was working on a whole different live coding system which also interfaces with SuperDirt, and for that I had to do some debugging of SuperDirt internals. Okay, start up this stuff again. Gonna take a little moment again. And then I think we wait for the wavetables once more. This is getting kind of long, the startup time. I should maybe look into ways of reducing that, but I'm not sure how much that is possible. Okay, we have title and SuperDirt running, I believe, so let's try these. Okay. Okay, there's something that's still not working. Oh yeah, it's because I have to start also OSC eval. OSC eval is my Emacs package for controlling Emacs with OSC messages. And I used to do that with Emacs client, which it was kind of easier in that I didn't have to start anything separately, but the latency was pretty bad, so I ended up switching to this OSC eval approach instead. Okay, but okay, now that works. So this is otherside elevator. The first element here is this kind of glitchy. This is actually also a chopped break. Maybe if I comment out some of this stuff, we can actually hear that. So you may be able to tell that there's like a drum beat going on, but it's kind of like cutting in and out. So that's just this Uela break from Uela Uela by Charlie Antolini's Power Dozen. They have this album Atomic Drums and it's really great. So there's a variety of things happening to it. There's shape, which is again a distortion. Not sure if this is big enough for the TikTok side. Maybe the TikTok people can tell me if this is visible or legible or not. But anyway, we also have a delay happening. We have some high-pass filtering. We have reverb, and the filter and reverb are controlled by this knob. But yeah, then there's a bunch of other things that go into it, like scrambling the chops, making it mono, although I'm not sure if this actually does anything right now. Adding reverb randomly. Removing some of the events with degrade by. Setting legato 0.9. Panning. Random DJ filter. And then ply with a pattern, and this is what creates like the glitchiness of it. So yeah, that's the first element. Then we can have a kick. And there's a bunch of variation code here that's not really doing anything because I ended up just having one variation of the kick pattern. But yeah, this is pretty simple. It's just a Lin kick. Playing on the first beat of each bar and every fourth bar also the very last 16th note. And a bit of distortion on that. Then we have... This is where the rest of the drums live. Or I think... Well, almost all of them. Oh no, sorry, this is the snares. Which we can obviously hear. So there's 3 different snare and clap patterns happening here, and I have these 3 variations, determining which of them are played. So this is the current variation, variation 0, and that's playing just the snare. Then the second variation is going to play both the snare and the clap, and then the last one is going to play only the clap. And we can change that just by tweaking this variable. And also the way I have this set up is that very similarly to what I did in Super Glider 2, I can hold down one of these variation selection buttons and click on the pattern knob, and then you'll see here it changes the variation. And reevaluates the code block. So that's super handy. Then we have... this is where the rest of the percussion lives, so... it's hi-hats, shaker, and snare. There's like, I think an extra snare, something like... maybe not ghost notes, but something in that general direction. So if I play the first variation of this, so this is the hi-hat. Yeah, I guess I could have commented also on these snares and claps, but I mean, whoops. It's basically just fairly simple note patterns with a particular sample on the clap here. There's some legato to like put some space between the 2 claps. High pass filter, shape, distortion, speed to control the playback rate. This one is written in quite a complicated way, but it's just... it's just putting that final clap on different positions each cycle, so it's switching between 2 different ones. And the speed is changing on every cycle, alternating between 0.4 and 0.5. There's shape, there's high pass, and so on. And there's delay, which I can bring in by turning up the knob. Okay, so D3, that's the hi-hats that we're already hearing. It's actually a ride sample, but I just shortened it by putting a very quick release. And there's kind of this rising gain pattern that goes into it. I'll turn off all this extra stuff for now so it's easier to hear. Oh yeah, so here I'm doing something where I shift the pattern 1/16 to the left. I guess it was just easier to write this way. Without the release, it would sound like this. Yeah, there's also a delay on this one. supposed to be another thing that happens with the knob value here. Oh yeah, it's not happening because I have it commented out. So this is adding kind of like a jittery effect to this. So by turning up the knob, we can kind of like mess with the rhythm, kind of like destroy the consistency of it. And yeah, this is using ply with a random count. I forget how exactly all the parts of this work, but it's fine. Okay, then we have... Oh yeah, there's also some panning, which only takes place if I have the knob turned up. Okay, then in the second variation, we also get this little shaker. Not much going on to it. It's just this bit here. And finally we get these ghost note snares or whatever you want to call them. So here I have this is like the bass pattern. Let's see. So this is what it sounds like if I just use like one sample, but then I'm varying the sample with this sequence of sample numbers. Then I'm using apply to sometimes stutter those snares, and then I'm masking the sequence so that one of these ghost snares never ends up on the beat, because there we're already gonna have the other snare. So it's just a way of making space for the main snare in the track. Okay, then we get to D5. This, I believe, is the bass line. This is a fairly simple one. And here I'm again doing this thing where it's like monotonous to begin with, but then with the variation I can give it some more progression. So basically that happens by deciding this note modulation pattern depending on the variation. So if it's 0, this is touched 0, so it does nothing. Otherwise we have this kind of note sequence here, which gets added to our main note sequence, which is this one. And then for some reason I'm adding note 0 here, which does nothing. I think I used to have the bass line on a higher octave maybe, or at least I was experimenting with that, and then this just got left in here. The synth for this is one of my own, but it's like a basic sawtooth wave with a filter envelope, so I'm not gonna go through that. But basically these parameters just set the envelope of the filter basically. So it starts off at the 64th harmonic. That's a way of setting the filter cutoff relative to the note that we're playing. So basically 64 times the frequency we're playing, and then it goes down to 4 times the frequency in a duration of 20 milliseconds and with a curve of -2, which kind of bends it downwards. And there's some distortion and envelope parameters, and that's it. Number 6, this is the pad. This is using a pretty interesting synth that comes with SuperDirt called Super Primes. It has quite a lot of movement going on with it, and you can switch up the character a little bit with this voice parameter, and so I have the knob here mapped to different values of voice. So when I turn this up, it's kind of weird because some values make it brighter, but it's not like monotonic, so that a lower knob value is always darker and a higher is brighter, but there's like it kind of goes in waves up and down. So kind of difficult to control with intention, but I try anyway. And so then we have attack, shape, legato, hold, high pass filter, delay, basic stuff. Then we get into what I believe is, or what I'm calling like the main melody of the track, which comes in quite late actually, but so this is using a wavetable synth. I don't know what this wavetable is, I just try random numbers here till I find a nice one, but it sounds like a square wave with some maybe filtering or some kind of modulation. But yeah, that's basically what these parameters are controlling. So I have like a table envelope which moves through the wavetable over time. And there's a bit of randomization in there which gives it just the slightest bit of variation. Then I have attack and release, panning. You can maybe hear that it slowly drifts from left to right, and there's obviously delay, low pass filter, which is controlled by the knob, and also the legato increases with the knob value. And for this one there is also 2 variations. It's quite a subtle difference, it just changes some of the notes. Like basically at the end of every 4 bar or 2 bars. No, 4 bars. It does something slightly different. Adds what you could call ornaments. Not sure what PS is here. Oh. There's something going on with squeeze, which is where I think what this did originally was like an arpeggio, but that's not really there anymore, so I'm not sure if this is actually doing anything. What it probably is doing actually is like dividing up each note, so let's say we didn't have this, but we had 0 instead. Yeah, this is what it sounds like normally, but then the squeeze here is doing like the varying rhythm. And yeah, that is that melody. Then there is another melody, which is made with a 303 emulation or something like it. So again, we have filter control with the knob. There's some slow panning, delay, but mostly this is just the note sequence. Yeah, there's not even any randomization in this one. It's quite straightforward. Then we have another melody. Let's start with variation 0, actually. Again, with the cutoff or something like it mapped to the knob. What is it actually? Yeah, it's the LPF, low pass filter cutoff. And also apparently this controls attack, so when the knob is all the way up, the attack is 0, otherwise it's a bit softer. And it's another wavetable synth with a random wavetable from my collection. This is the main note sequence. Then we have this mod thing which gets applied depending on the variation. And we just have 2 variations, but the second one is that we superimpose this quite complicated structure variation of the pattern on top with a higher octave. Oh, and it's not just the superimpose, but we're also segmenting the original notes here with varying numbers. Okay, what is number 10? Oh yeah, this is like symbols and reverse symbols that I can easily trigger. At the next cycle boundary, so this is just the symbol. This is reverse symbol leading out into the symbol. Then we have something more. Oh yeah, kind of snare roll into the symbol. Yeah, this is all using my trans in-out transition in-out function. Maybe I should show that, because it's one of the more interesting things here. So here is how I defined trans in and trans out, which is what trans in out is built from. So trans in MNP means play pattern P for up to n cycles before the next cycle divisible by n. So this is used to do like things that are patterns that precede, go into the transition point, and then trans out is used to do things that go out of the transition point. And it's all based on this title mTrigger function and also filter when to make sure the pattern only plays at certain times. And then with trans in out, it's basically just stacking calls of trans in and trans out. And so here we're aligning all of this stuff to 4 cycle boundaries. And then the input pattern, or the ingoing pattern can be at most 1 cycle long, whereas the outgoing can be at most a quarter note long. And the in pattern here is then, depending on the variation, that's going to be either silence or the reverse symbol type of thing. I do not remember how this works, but anyway, or then the snare roll defined here. And the output pattern is just bass, which is this thing here. So that's just a single symbol. Okay, that is otherside elevator. Then let's go to Secret Star. This is, in my mind, like a sibling track to Otherside Elevator, because it's also kind of a down-tempo generative melody type of deal. So the first element here is going to be the melody. And so here we have another generative melody type of thing. So let's see. It's again wavetable synth. Just trying to simplify this a bit. So this is the like basic pattern that we have going on. Then we apply some octave shifting to that. Then we do the delay, I suppose. And then there's another kind of echo here, which is like a event echo or a MIDI echo type of thing. So when I turn up the knob, okay, so there's the echo, but maybe more noticeably you can hear the release time getting longer. So that's another thing that happens with this one. Then we have a drums pattern. Starting off with a kick and hat. Pretty simple patterns here. A bit of reverb on the hats. Also putting them in a different orbit. Then variation 1. That adds a snare and a clap. Both of which are very simple patterns. And then there's a final variation which adds some drum breaks. This one. And by tweaking the knob here, we apply width 2 with a speed control that varies between 1 and -1, so we're getting some backwards events as well. And it applies to all the drums, which is why I have all of them in this one pattern. Okay, then there's the bass line. It's not like a super beefy bass line this time around, because I guess this one goes from like a contemplative mood, so I felt like the bass here should be a bit more low-key. And here we also have two variations, but again, wavetable synth, using some random wavetable. There's a bit of an automatic LPF, low pass filter cutoff control here. You can hear that if you pay close attention. Then we have the variation, which basically just changes the note pattern. So that's for doing these sections of the bass line where we go like 2 notes down. And I have to do that manually, there's not like a changing thing. Oh, hello Jade Rose. Oh, so many wires. Sounds dope. I guess the wires comment was earlier, not sure which ones you mean, maybe the ones on my table. Yeah, there's a lot of wires here. I've said this before, but some people are obsessed with making like a very tidy and minimal workspace, and I just cannot work like that because I'm always plugging different things in and changing routings and stuff, so I end up with a lot of wires. Although I have improved on that situation with this patch bay that you can maybe see behind me here, or to the side, for audio and HDMI connections. Nesting, I do the same thing, yeah. Oh, by the way, I forgot to mention this, but I've been listening to your album also quite a lot and really enjoying it. It is now on my work playlist rotation. Really nice stuff. And so, even though this album is about my stream, you should also all go check out Jade's album, because it's great. Okay, next element is the pad. So, yet again, it's a wavetable synth. I think maybe everything here is. Yeah, probably. Yeah, because this track actually started off as a demo of the wavetable synth. So then I guess I ended up doing everything with that. So this pad is another random wavetable. But here I'm using the LFO to manipulate the wavetable index with this table OSC frequency and table OSC amount. And again, we can turn up the knob to open up the filter here. And this one also adds some delay when the knob is turned all the way up, kind of creating that like drenched in pads type of thing. Nice way to create some life into the sound. And then finally, this is a very simple track. There's only 5 elements, but the final one is the mellow 2 or melody 2. It's a bit hard to hear unless I turn up the cutoff. And there's a bit of reverb on there with a randomized room size. And then the track is just messing with these live. Yeah, by the way, I'm not sure if I mentioned this before, but all of the tracks on the album except for Yaoi Gagarin, which I showed earlier, which is like a fully defined composition in Sonic Pi, but all the other ones are actually played live with this controller. And so it's like a single take for the most part. There's a few where I had to go back and take or do a retake of some instrument, and then because I was mixing most of these in Bitwig, so then I was able to do that kind of thing. But all of the tracks are tracks that I could have played fully on the controller in one take, but to save time I did some small corrections here and there, because I'm able to record these to a multi-channel file from Super Collider, so that's very easy to just pop into my DAW and mix it over there. Okay, we have 2 more tracks to go, so I think we're doing maybe fine on time. So for those who need to hear before, I have about 40 minutes left before I need to go. Okay, timestamps is the drum and bass climax maybe of the album. It's certainly the most intense track, I would say. So this one starts off with something really weird. Actually, it doesn't start off with this because it's the wrong variation. So, this is probably one of the more complex patterns I've written, but what's happening here is there's a vocal recording from TikTok user The Supreme Kaya. She did some years ago this kind of thing where she sang some vocals and asked people to duet it, and I did, and I made a duet with title that's actually totally different from this track, but because of that I put the vocal sample in my library and it stayed there, so I ended up using it here as well. But now it's like completely mangled for the purposes of this track. Let's see if we can simplify this a little bit. Let's get rid of that. Wait, where am I even? Oh, there is the stack. Okay, so... Okay, this might actually not be that easy to simplify, because weird things start to happen. Or maybe it's the loop ad that I need. Okay, well, you cannot really hear the original melody that she sang, but it's in there. So that's this bit here. Then there is, because we're now in variation 0, there's also this one. So let's can we do this? So this is now just the vocal chopped. And then I add these samples from this one has a long story, but it's like there's kind of a sonic sculpture in the Aalto Otaniemi campus. It's like a pine cone with motors. You press a button and it like opens and closes, and it makes wonderful sounds from just the motors and the metals like screeching. So I recorded that, then I put it through, what was it? I think it was some kind of tone transfer model when I used to work with audio deep learning. And then this came out, and then I'm sampling that here and chopping that up also. So it's like a long chain of processing. Okay, then variation 1. And there's all these manipulations that happen to like mess up the sounds, but I'm not gonna go through all of this, it's just too much. Also, I don't really understand most of this anymore. Variation 1 adds this break, which is actually from the Prodigy's Narayan song. Do you use deep learning for sound design? Not so much anymore. I was into that for a short while in like, I guess around 2019, 2020, right before the pandemic hit, is when I was working in a research group looking into deep learning with audio. And we made some experiments for like running mostly Google Magenta deep learning models in pure data. And yeah, we were always training them with our own sounds. So for those of you who might know deep learning or AI from what it is today, which is largely based on non-consensual scraping of data from all over the internet, that's not what we did. We used our own samples for everything, all the training. So yeah, when I was working there, I made various sound design experiments with deep learning, and this was one of them. But personally, I concluded from that research that the computing power needed to do that stuff is maybe not actually worth it, considering the results or the output. So I kind of have not been doing any more of that, and instead I've pivoted more towards doing more with less, as I like to say, which involves running title cycles on my, at this point, 11-year-old laptop, and also SuperGlider 2 on this old iBook here. So that is more the direction of my music nowadays. But I mean, this sample in particular I've found very useful in many contexts, so of course, why not use it? Okay, that's all about deep learning for now. But yeah. Here we get that chopped drum break in the mix as well. Rather, if I do this. Then these other variations also are like more continuous. They don't have this break in them that the earlier ones do. So it's like a constant flow of breaks and... Okay, I'm saying breaks in two different meanings of the word. One was breaks in the audio, the other was drum breaks, but okay, maybe you get it. Yeah, that's gonna be that pattern. And maybe one fun thing about this pattern is that the vocal part of it, it does not really align with like the 8-bar structure that I'm using for this track. So then it's kind of surprising when the kick starts. Or kick and snare and whatever else is in here. So this is a basic or fairly basic drum pattern with like kick, snare, snare 2, which we're not hearing right now, I think. Or are we? Oh yeah, it's like the... Yeah, there's two snares happening. There's like a ghost note and then the main one. Then if we go to variation 1, we get some more hi-hats. And here I'm again using this trick, or whatever you want to call it, of switching between different hi-hat samples in strange ways to add some variation. And with this one, turning the knob, does some scrambling and also this plywidth thing here, so kinda messing up the rhythm. Then we've got the bass line. That's not the bass line, that's a snare roll. Okay, I forgot this one. So yeah, as in the previous, or not in the previous track, but in Otherside Elevator, I can do these snare rolls here. Just synced up with the next 2-cycle boundary. And then we come to the bass, which is super Reese. Fairly simple pattern here. Can also be filtered, which I do during the break in the recording of this track. And then we've got this chiptune melody. Again, nothing super complicated. The bass pattern is just this, and then I do like a octave shifted delay with superimpose. And the voice parameter here changes the tone a bit randomly. So there's some knob control. The knob controls the release here, so it gets longer. Oh, and also more reverb gets added. Then we have this melody. And the sample here, maybe I can show you that actually. Here. Let's get it on this screen. So this is actually just a recording of me singing or saying the different vowels, going from U to I to I. Oh, maybe I'll just play it. It's been heavily pitch corrected, which is why it sounds so robotic. But this is a really fun method of how should I put it? Making kind of like a synth voice, because when you sing the vowels like this, like in a continuous morphing fashion, then you can play it back at different positions in the sample, and then you have like some kind of filter effect or formant, or yeah, I guess formant is gonna be the right term for that. So here we can see that I'm modulating the begin parameter, which is exactly that. It determines where to start playing the sample. And there's filtering, pan, delay, all the standard stuff. Yeah, really nice technique. I intend to explore that for some other stuff as well. And finally we have these vocals. Which is just me singing "They don't know," because they really don't. And then I can bring in some echoey effects here. Well, this is more than echo, it's also this kind of glitchy fly effect happening here. And this is the echo. And this one also has another variation, which is where I just change the pitch a bit. So here I'm using one of my own functions called cond app, or conditional application, and what that does is just, if this is true, then apply this function. And the function is just adding some numbers to the note sequence, so then we get a bit of pitch variation. Okay, that is timestamps. And on to the final track, Vermilion Starlight. The file might be called something else. Now I have to remember what it is. Oh yeah, I should rename this actually. There we go. So, Vermilion, Starlight, the final track of the album as well. This was kind of an experiment initially with custom arpeggiation in title. I think based on Geika's get rap function, which they posted in the Discord. And so I ended up making my own version of it called get rap ext, where ext stands for extend. So the way this works is how does it work? Let's see a usage of it. Oh yeah. So the XS parameter here is typically in the arpeggiation use case going to be a chord, so a list of notes, and I is an index into that list, but I might be greater than the length of the list, -1, or it might be less than 0, and I wanted to handle those cases by like the easy thing to do is just wrap around, but I wanted to wrap around and also add or raise or lower the octave depending on whether it's below 0 or greater than the length -1. So to that end, I just do this div mod calculation, which is a Haskell function that it computes the divisor and the modulo at the same time. And then based on that, I used the modulo or modulus. Anyway, I used that to index into the list, and then I add the divisor times n, which in the case of adding or removing or raising or lowering octaves is going to be 12, as it was down here. So what does that actually sound like? Well, this track starts with this super cheap melody, which actually doesn't use get rap ext, but let's start with that anyway. So, you know, pretty simple super chip usage. I mean, here we have the bass pattern. Then we use echo width to add some higher octaves with random echo lengths. Then we got the low pass filter. And finally the delay. No controls on that. Okay, on to the next one. We have the kick. So this is samples from my Volca kick synthesizer. So dry, they are not nearly as fried as they get when I add SMNI and SMNth time. So SMNI and SMNth time is my super dirt implementation or super dirt port of the Barry's Satan Maximizer distortion, and the original version of this, or like the original Super Glider version of this, is made by Snaphiz, and it's on sccode.org. So pressor with some really extreme values, and that creates these harsh distortion effects. this is just the drum break. You should add it to Super Dirt. Sorry, had a bit of a connection hiccup there, I think. I was in the process of saying that, yeah, maybe I will make a PR for Super Dirt. Although, I wonder what the license is for code posted on sccode.org. Is it even defined? I don't know if it's stated anywhere. Well, that's something to look into. Yeah. But yeah, it would actually be a pretty good addition to Super Dirt, because there's, I think, a couple of distortions in their shape and maybe like a clipper. Something like that. I forget. I only ever use shape and then this Satan maximizer. Anyway, yeah, I was on these drum breaks, so this is a pretty straightforward playthrough of this one sample here. Although there is this chopping going on. Then we have an added snare on top. Oh, I think this one is the crash symbol. Yeah. So this Viva la Revolución loop is from oh my god, what is the artist called? It's from the Serial Experiments Lane Siberia Mix soundtrack. Let's find that. I think I have it in my history. Yep. It's this Professed Intention and Real Intention track by Chikoda JJ Wasei. So that is where both that and then this drum sample or drum loop is from. Although this is quite heavily modified. Let's try it with just this. This is what it sounds like originally. Then it gets chopped, applied, a bit of phasing with a short delay, some backwards and forwards, playback, and random panning. Okay, then number 6, I believe, we have this Super Hammond, another Super Dirt built-in synth. And it doesn't really sound like a Hammond right now, but that's because I have the bit crusher on here with cores. And I guess Hammonds have a sharper attack than this anyway, but yeah, that's fairly simple pad. Just have some attack on release on there, and yeah, side is one of my own title functions, so it does mid-side processing basically, so it turns a stereo signal into a mid channel and a side channel, and then I can control the volume of those separately. So basically what it does is it turns the signal into mono by setting side 0. And then I have to use my own panning mid-side pan, because the normal pan happens before the mid-side processing, so this is just another panner that goes after it to get that stereo movement here. But yeah, I didn't like how the original stereo field was. Wait, is there even any stereo field here? No, it seems to be mono. I think I was originally maybe using a different sound here which had stereo information, and then I just wanted to get rid of that. Then we get to the melodies near the end of the track. So here's the Super FM. Although I'm really using this as a sine wave because there's no actual FM happening here. And basically going through each of these note sequences for 2 cycles before going to the next one. And using note take, which is the I forget what that's called, but it's this title feature where you, on each event, you take the next element from the list. So instead of being like defining the pattern, you take it from list. So it's another arpeggio type of deal. We got release here, legato, delay, panning, another bit crusher. Without the bit crush you can really hear that it's the sine wave. Then we have more melodies. And here's where I'm finally using the getWrapExt function. So I have this pattern of chords, and then with this getWrapExt, this bit here basically defines how to index into those chords. So I have like my own custom arpeggio sequence here. 0, -1, 1, 2, 0, 2, whatever. This is quite a nice alternative to the built-in arpeggiator stuff, which has like a few fixed patterns. So you can do more complex stuff this way. Then I think there is one more melody, because I really went crazy with the melodies on this one. Again, using get-rap-ext. And I think here it's the same chords as on the previous one, but a different arp sequence. And the little twist here is that at the end of each 2 cycles, I do these 30-second notes, just for that tiny bit of spice. And in this track there's not a lot of knob mappings. I think, yeah, this is actually the only pattern that has some knob mapping. Or does it? Oh yeah. Oh yeah, it changes the attack. So here it's just a sharper attack than it would be normally. And with that, with honestly impeccable timing, because it's 3 minutes to 10, which is my deadline, we are done. So that's how I made all the tracks on Nested. And yeah, if you haven't yet, feel free to go listen to the album, and if you like it, I hope you'll consider buying it. It is on pulu.bandcamp.com, and it costs €7 or more if you like. Yeah. That is gonna be it for this stream. Next thing I'll be doing, I'm in the process of writing a PHP live coding system, and I'm hoping to have it ready before the Top Lap Solstice stream, which you can find the sign up right now at oilerroom.com. There's still a few open slots. Mine is December 21st at 10:45 in the evening. That's Finnish time, so if you go to this site, it'll show it in your time zone. And yes, I'm hoping to do maybe the world's first PHP live coding performance. I don't know if it's the world's first, but I couldn't find any other live coding systems written in PHP, so it could be. Oh, hello FML1989. Okay, that sounds interesting in PHP. Yeah, it has certainly been interesting to develop. I'm not super far with it yet. Just this week I actually made it do the superdirt handshake. So the idea is that it communicates with superdirt and plays the superdirt synths. So I can use all the stuff that I already have created for Title, but with PHP taking care of the pattern logic. And yeah, this week I got the superdirt handshake working, and the next thing is to make a proper scheduler. Right now all it does is play like quarter-second events and nothing else, so that's a bit limiting. But I have already like a plan for that, like the code is taking shape in my head, I just have to find the time to do it. And I mean, there's time before this event, what is it, 9 days, so hopefully I can make that happen. Okay. Okay, I'm gonna check it out for sure. I do PHP for my day job. Yeah, that's the thing. I'm also doing PHP for one of my day jobs at the moment. And it's funny because PHP is a very nostalgic programming language for me, because it's the very first one I learned back in like 2002 or so. And the reason was I wanted to make a website to host my music that I had started making at the time. But then a couple of years back, I somehow ended up making WordPress-based online course platforms at Aalto University, and that is of course PHP. So I got back into the language, which is a lot better nowadays than it was back in 2002. But yeah, that kind of gave me a new appreciation for it, because as you might know, PHP is maybe not considered a good or elegant language by many people. It gets a lot of criticism for being ugly and inconsistent and whatnot. But having come back to it after all these years, I'm still starting to see the beauty in this language. And if not the beauty, then it sort of appeals to me in this anti-elitist way that programming languages don't always have to be like these beautiful diamonds of programming language theory and design. They can be like these more practical things that people still accomplish wonderful things with. Like a lot of the web runs on PHP, as I'm sure you know. So in that way it also appeals to me, and in my imagination there's all these people out in the world that are PHP programmers who are not getting into music live coding because there is no music live coding system for PHP. So maybe I can be their gateway into live coding as well. But yeah, that's the grand plan. We'll see how it works out. And yeah, so tune in on the 21st, or it might be the 22nd depending on your time zone. Just check oilerroom.com. And I mean, there's a whole huge list of great performances that are gonna be happening, so be sure to check those out as well. Yeah, it's night and day comparing 5.3 and 8.2. It has gotten really structured nowadays. Yeah, I mean, version 5 was already quite a big improvement, because I started on 4 point something. Maybe 4.4 or 3, I don't know. It's been so long. Because I don't remember when 5.0 came out, but in any case, my web host at the time only had 4 point something. So that's what I got started with. Yeah. That is all I have to say, and I need to go grab some dinner because I'm getting super hungry. But hey, thank you everyone for tuning in and chatting with me and following. And to everyone who bought the album, huge thanks. I really appreciate the support, and it helped me order a new router that I hope is gonna improve my internet situation. And if not, then at least, because I'm not sure actually where the problem is. I'm suspecting it's the router, but it could be something else. But either way, the new router is gonna help me make a bit help me with making my network setup a bit more flexible for various things. Like I'll be able to run a VPN on it and that kind of thing. And it runs OpenWRT, so it's like open source software, which is nice. Yep. That's it. Thank you. Buy the album if you haven't already. Tell all your friends. Like, follow, subscribe, press all the buttons. Tune in to the Oiler Room stream. And all the good calls to action. Thank you. Good night. See you in the future. Bye bye.